Developing the equations of a parabola from the geometric focus and directrix viewpoint. So, looking at this graph here, of course, the focus is here and the directrix is this line down here going across here. And xy is on the parabola only if the distance to the focus is equal to the distance to the directrix. So we're going to develop the formula for this parabola. Okay, the P is the defining distance where 2P is from the focus to the directrix. So it's 1P from the vertex to the focus and P the distance from the vertex to the directrix. So on this drawing here, in this orientation, the focus is at 0P. 0P right there. And the directrix is the line y equals negative P down here. Y equals negative P. So the distance from the focus to xy. From focus to the xy, that's D1. That's going from 0P, that's this focus location right here, 0P, to the point xy. That's the point xy, right there. So D1 is this distance formula, delta x, x minus 0, squared plus y minus p squared square root. That's what D1 is. And you simplify that down and you get this part. Now let's figure out the distance from xy to the directrix. Xy is here. The directrix is down here with this line. The point on the perpendicular line, distance line right here to the directrix has x coordinate x, because it's the same coordinate as xy because it's straight down from there, and it has y coordinate negative p because that line there is y equals negative p. There's the distance p is below the x-axis, so it's y equals negative p. Okay, so that's the 2 points, x negative p and xy, and we're going to find the distance d2. So that will be the delta x. The delta x will be x minus x squared, plus the delta y is y minus a minus p. Either way, direction you do it, you're going to square it anyway. So that's y subtract negative p, and that's being squared. So you simplify this down and you get x minus x right there is just 0 squared. So you get the square root of y plus p squared. The square root of something squared is y plus p. You get that. Now, for xy to be on the parabola, the whole idea is that d1 has to equal d2. These two distances here and there have to be equal, or else xy is not on the parabola. So you're going to set d1 equal to d2. Okay, now, d1 is equal to d2. Now, you square both sides, and you get this on the left, you get this on the right. Now you're going to copy down the x squared. Now you're going to square out this binomial. You get y squared, multiply together and double, plus p squared. Then on the right, you're going to get y squared, multiply together and double, 2py plus square the last p squared. Now something very lucky happens at this point, p squared cancels out with p squared on this side. And y squared cancels out with this side. So then you're left with this equation. Now all we're going to do now is add 2py to both sides, and we're going to result in 4py on the right. And that is the equation. Now I want you to realize that you could divide by 4p and get this form, and you recognize that as a parabola. These kind of equations, and we could write 1 over 4p as some number a. We worked with those before, and we were calling those parabolas. But I told you in those earlier videos that at the end, later, we would actually prove this actually does graph as a parabola. Because a parabola really is a geometrically defined set of points. So now we can believe from the beginning that y equals ax squared and all the things we did with that, and we were really working with parabolas. Okay, now let's do an example with that to basically believe that this formula is working. So we have, let's let p equal 2. Then x squared equals 4py. 4py. So x squared equals 8y. Which means that for graphing in the calculator, y equals 1/8 x squared by dividing by 8. So there's the y. There is the directrix, because the p is 2. The parabola has a vertex of 0, 0. We'll talk about later how there's some where you can move it around off of 0, 0. So anyway, we graph this, and we see the focus is going to be here. The directrix is over here at y equals negative p, which is negative 2. And I put some point on the parabola here. And I wanted to see if the distance really looked equal, like it's supposed to. And it does. And if you tried another one over here, some point over here, and went like this, and down like this, those two would be equal also to each other. So this is all working and it's all correct. Okay, now the other cases of opening down or sideways all develop similarly, but you don't have to know that development. All you have to do is know these forms here. Okay, so opening down, you have y equal p, the directrix up here. The focus is down here at 0, negative p. The form is x squared equals negative 4py. So you can remember, if you solve this for y, you'd have a negative number in front of the x squared, because the p is always positive. Okay, and that would just turn it down. Okay, then right and left here, when the square is on the y, that's when it opens sideways, and if it's a positive number, it opens to the right, and if it's a negative number in front of the x, it opens to the left. And by the way, both of these sets of points, they're relations, but they're not functions, because they break the vertical line test by crossing in two different points vertically. So the recap is right here. Here's all the forms that we have, and all you have to know and remember is that when the square is on the x, you're opening up or down. When the square is on the y, you're opening sideways, and the plus and minus decides left or right or up or down. And just so you know, we can move the vertex off of 0, 0 to hk, and you do the normal way that we've seen, x minus h, y minus k. In every case it's like that, y minus k, x minus h, those are all the same. And then we have the same forms as we did right above. You can see that they're the same. All you're doing is plugging in x minus h and y minus k in, and you get these. And now these are all parabolas, opening but vertex is at h comma k instead of 0, 0.